What if one algorithm could optimize your budget, plan workouts, pick stocks, even manage your phone's memory? That's dynamic programming. And today, we're mastering its most iconic problem, Knapsack, in C++. By the end, no face, no fluff, just logic, code, and clarity. Picture this, you're a thief. You break into a house, and you've got a backpack that can only carry so much weight. In front of you, items with different weights and values. What do you take? What do you leave? This is the 0x1 knapsack problem, a classic in computer science. Brute force, too slow, time complexity explodes. Instead, we use dynamic programming. Define dp I, w is equal to the best value using the first I items and a knapsack of weight w. For each item, we choose, take it if it fits and add its value, or skip it and move on. We store and reuse subproblem results in a table, cutting complexity from exponential to polynomial. Let's witness its implementation in C++. Step 1. Inputs when number of items and knapsack capacity have been initialized alongside weights of all the items and their values. Step 2. We create a DP table. Step 3. Fill DP table. Step 4. We print the result. That's it. Simple, efficient, and highly adaptable. To recap, this algorithm powers decision-making in finance, optimal investment strategies, e-commerce, maximizing delivery truckloads, gaming, managing inventory or skill points, embedded systems, balancing memory versus performance. Wherever you have limits and need to choose wisely, this pattern shines. Want more real-world problems decoded with C++ and clean logic? Smash that subscribe, hit the bell, and drop a comment. Should we tackle longest common subsequence, rod cutting, or something else next? No shortcuts, no hacks, just smart code. See you in the next one.